Trig equations with identities. Sometimes when you're solving trig equations, you need to do identities, but they usually stand out. Like if you see a double angle, like cosine 2x, that's a double angle, you're going to use a double angle identity. Now cosine double angle has a couple of options. The one I'm going to use is 2 sine squared x minus 1, and that's equal to cosine x because we didn't change the right side. Now knowing which identity to use, well, for cosine there's a couple of options. For sine and tangent there really aren't options, so when you see a double angle you use those. But for cosine you might have to try a couple of them, play with them. This is the one that I found to work best. Is it possible to use the other versions? Probably, but this is the easiest way to go. But sometimes it takes some experimenting. Now here I recognize I have a cosine squared. A cosine, to me, that says factoring. And I want to convert these cosines into just x's, so it's a little bit easier to work with. And I'll convert that back to cosine x later. I gotta get everything to one side, because then I'm going to factor here, and we end up with 2x squared minus x minus 1 equals 0. Now this is a trinomial that we need to use AC factor by grouping with. And just to show you real quick, AC, is first and last terms. That's negative 2x squared. So I can split this into negative 2x and positive 1x because they add to negative 1x and multiply to AC negative 2x squared. Bring down 2x squared, bring down minus 1, cut it in half, GCF on the left, GCF on the right. Take out a 1 if there's nothing. Quotient's got to match, and they do. 2x plus 1, x minus 1. Remember to keep it equal to 0 because it's an equation. That's a pretty basic AC by factoring problem there. You probably could have just figured out 2x and x and played with it a little bit, but that's how you would have to do it. Set equal to 0, so we set each factor equal to 0. And then solve for x in each group. So minus 1, that's 2x equals negative 1, divide by 2. X equals negative 1/2, and really we're talking about cosine x equals negative 1/2, and over here add 1, x equals 1, which is really cosine x equals 1. Now I don't want my ratios, I don't want cosine x, I want x, and I want it over the intervals not including 0, but 0 to 360, including 360. And so I'm kind of doing inverse cosine here, arc cosine. What value of cosine, what angle of cosine is negative 1/2? Well, see, I know it's negative, and so cosine is going to be negative, so I'm thinking about the second and third quadrants here, where cosine can be negative 1/2. Now I know cosine of 1/2 is 60 degrees, and that's just one of those angles that you should have memorized at this point, but your calculator will confirm that for you. Let me get my calculator up and running to help us with this problem. Again, I don't really need it for a basic angle measurement like negative 1/2. Activate? There we go. So that'll pop up in a second. But it's a good tool to use to check our work. So I know a cosine of 60 is 1/2, and I'm thinking, all right, what about in the second and third quadrants? So let's see. Let me just verify that. Cosine 60 is indeed 1/2. All right, so where is cosine negative 1/2? Well, it's going to be the reference angles of 60 in the second and third quadrant, where cosine is negative. And 60 degrees in the second quadrant is 120, because 180 minus 120 is 60. And 60 degrees in the third quadrant is 240. And my calculator can check this for me too. I can type in cosine 120, and it should be negative 1/2. Cosine 240 should be negative 1/2, and they are. So I know my answers are right. Once you get to cosine x equals negative 1/2, it's really easy to check the angles that you get. Just type them in and make sure you get negative 1/2. So you should always check your work that way. And then over here, cosine x equals 1, I think, all right, where's cosine 1? and this is another one you should have memorized, second cos 1. It's at 0. Remember, we're not including 0, but there's another angle that cosine is 1. Remember, if you think about it, we know our angles of, 30, 45, and 60, but there's also 0, 90, 180, 270, and 360. Remember, for the unit circle that it goes, x comma y for coordinates, but that's really cosine sine. So we're talking about the x value here. And at 0, it's 1, 0. At 90, 0, 1. But we want the x value of 1. So this is the only place that it works. But we're not using 0, but remember 0 and 360 are also the same values. So these are my 3 answers for x.